Hi, in this video, our group will be presenting Experiment 6 High Performance Liquid Chromatography. So this is our group members.
Introduction. High Performance Liquid Chromatography (HPLC) is a laboratory method that enables the highly efficient separation of small amounts of the components in a mixture. Compared with other chromatography, the HPLC is more advanced. The pump forces the solvent through the system under high pressure, which shortens the separation time and boosts efficiency. Besides, the column in HPLC contains smaller stationary particles of only 5 micrometer diameters compared to standard LC, thus providing superior resolving power when separating mixture. The HPLC components consist of solvent as mobile phase, pump, column as stationary phase, detector, and waste. HPLC also consists of diode array detector, DAD, to measure how much light a sample absorbs at different wavelengths. HPLC components function. Firstly, solvent as mobile phase to carry the sample through the stationary phase. Secondly, pump to force the mobile phase to flow through the packing. Thirdly, column as stationary phase to separate each compound contained in the sample. Next, detector to signal when eluents are coming off the column and fraction should be collected. Moreover, waste reservoir to collect the mobile phase and sample components after pass through the detector. Next, injector to introduce the sample into column manually. For the output reader, it consists of computer safe and printer that function to receive and display the data or output read by detector and create chromatogram. Lastly, injection components consist of filter membrane, shrink, and tube that each function to filter the sample before injected, to force the sample into manually injector, and to hold the sample. The objective for this experiment is to determine the retention time of a standard solution, caffeine. Secondly, to identify the caffeine peak in a soft drink sample. Lastly, to determine the amount of caffeine in soft drink sample using the response factor method.
For apparatus, we're using beaker, burette, glass rod, volumetric flask, dropper, and shrink. For chemicals, we're using caffeine standard, soft drink, distilled water, and acetonitrile. Preparation of sample and solution. Caffeine standard solutions. Firstly, we're going to prepare stock solution, solution A. 10 mg of caffeine was accurately weighed into a 10 ml volumetric flask, then it was dissolved in distilled water. After that, the solution was made up to volume with distilled water. Secondly, we're going to prepare working solution, solution B. 1 ml of solution A was pipetted into a 10 ml volumetric flask. Then the solution was made up to volume with distilled water. Sample preparation. 10 ml of a soft drink sample was poured into a small beaker. Then we used glass rod to stir to remove any carbonation. Then 2 to 5 ml aliquot was filled through a 0.45 micrometer per diameter membrane filter to remove particulate matter. For methodology of HPLC, I will explain in the next slide. For this experiment, we are using DAD HPLC, which is diode array detector. This is the injector for this HPLC. In this HPLC, we are using manual injector. These are the shrinks, filter membrane, and the sample that we're using. This is the computer to run the software of the HPLC. Now, we have the mobile phase of the HPLC, and under it we have the pump. Then we have the column, which is the stationary phase. Here we have the detector. This is the injector, and this is the computer to run the software. Lastly, we have the waste bottle. Now we move to the first step. We use this shrink and we put in the filtered membrane like this. Now we're going to take 2 to 5 ml of our sample using this shrink like this. Now we are going to put our sample into the vial for our next step. Now we're moving to the second step, which is running the software. Firstly, we switch on the software and click the software icon. Secondly, click switch on button after we switch on all the HPLC switch. Number 3, we wait until all the compartments turn green and the software turn ready. Number 4, adjust the method. Go to edit and file method. Click everything, then click OK. For method format, put the samples information, then click OK. For injector, click manual injector. Number 5, fill the information about the sample such as flow rate, solvent, and retention time. We need to know the type of the sample and we can just follow the information from the lab manual. Number 6, we click apply, then we click OK. Number 7, fill the information about the amount of the mobile phase after the mobile phase has been refilled. Number 8, we change the temperature based on the sample used. Number 9, move to the next step after everything turns green. Finally, we move to the last step. Now, we are going to take 10 microliter of the filtered sample using this shrink. Then make sure the injector knob at load before injecting. After that, inject the sample and pull immediately. Then, we turn the knob into inject. Finally, the machine will automatically run the sample.
This is the result that we have obtained from this experiment. The retention time for caffeine standard is 0.849 minutes and the peak area of caffeine is 1.131 times 10 to the power of 4. Next, for soft drink sample for run 1, the retention time is 0.812 and its peak area of caffeine is 4772.152. Last but not least, for soft drink sample run 2, the retention time is 0.825 and its peak area of caffeine is 1.459 times 10 to the power of 4. And in this experiment, the soft drink sample that we use is Coke. Next, we will discuss about the question in this experiment. The first question is, state the types of compounds which are suitable for analysis using HPLC. The types of compounds that are suitable for analysis using HPLC are non-volatile and thermally unstable compounds. And the second question is, differentiate between the HPLC and the GC in terms of mobile phase and column. For high-performance liquid chromatography HPLC, the mobile phase used is liquid. The column for HPLC is short and narrow and packed with small particles. Meanwhile, for gas chromatography GC, the mobile phase used is gas. The column is long and narrow, and it has two types of column, which are packed and capillary column. Next, we will move into the discussion. First, I will tell about the step-by-step operating procedure of the HPLC instrument that we use in this experiment. The first component is solvent or mobile phase reservoir that contain the mobile phase with different polarity. Next, the pump will force the mobile phase to flow through into the HPLC column. The injector also will inject the sample into HPLC column, and in this experiment, we use the manual injection. Next, the detector will send the signal into data system and display so that the analysis can be done. And the remaining compound or sample will be forced to flow into the waste reservoir. Next is the component and experimental conditions of the HPLC instrument that we use in this experiment. The mobile test that have been used is polar, and this chromatography was done in reverse phase, which means most polar compound eluted first. The elution in this experiment is the isochromatic elutions, and in this experiment, we use the manual injector and ultraviolet detector. Next, we will calculate the calculations of caffeine in ppm in the unknown sample, given that the conversion factor is 1 mg over 1 ml equal to 1000 ppm. First, we need to find the response factor RF of the caffeine standard using the equation peak area caffeine standard over concentrations of caffeine standard, and it will give us RF equal to 113100 mg over milliliter. Using the same value of RF, we calculated the concentration of caffeine in ppm in soft drink sample using the equation peak area caffeine in sample over RF. After the calculation, we will get 42 ppm for the run 1 and 129 ppm for run 2. And the concentration of caffeine in soft drink sample for run 1 is 42 ppm, and the concentrations of caffeine in soft drink for run 2 is 129 ppm. Last but not least is the precaution step in this experiment. First, switch on the system, which is the HPLC first, and don't switch on the PC first. Next, make sure to filter and degas the sample before injecting it. And last but not least, the manual injection must be done as quick as possible.
In conclusion, we managed to determine the retention time of a standard solution caffeine as 0.849 minutes. Next, we managed to identify the caffeine peak in a soft drink sample, which is 4,772.152 for run 1 and 1.459 times 10 power of 4 for run 2 in area. Lastly, we managed to determine the amount of caffeine in soft drink sample using the response factor method. The response factor RF value of caffeine standard is equal to 113,100 mg per milliliter, and concentration of caffeine in soft drink for run 1 and run 2 is equal to 42 ppm and 129 ppm respectively.
This is the reference that we use in our video. That is all from us. Thank you for watching.